Lots of famous poets and painters have walked through these alleys of pine trees, but lots of scientists have too. Welcome to Monte Mario, the highest hill in Rome and the seat of the Italian Institute for Astrophysics. That's the perfect location to bring you our new edition of Space Roundup. On the menu today. After the names and faces were finally revealed to the world last November, we'll be asking what's ahead for the 17 new ESA astronauts.
In the next few months, the astronauts here in the European Astronaut Center will go through the basic training.
I will be talking to you about the next launch that is getting us all excited at ESTIC in the Netherlands, the Jupiter Icy Moons Explorer, which is due to ride into space this coming April.
We will also celebrate a birthday.
And then we declare success.
10 years ago, Europeans were able for the first time to fix a precise location on the map using their own Galileo satellites.
Good afternoon, Marco.
Nice to see you.
Thank you for having us.
We will be meeting with one of the team members who was in the room that day.
And finally, we'll take you to the place to be if you're interested in the weather. Last December, the first of a new generation of weather satellites was successfully launched into orbit.
And we are off.
Now, engineers and scientists are eagerly waiting for its very first images.
And there is even more to come.
So stay with us. The Grand Palais éphémère in Paris was buzzing with excitement following ESA's Ministerial Council in November last year. Not just because member states had backed ESA's ambition in space with a 17% budget rise, another much-awaited announcement was also made.
Lots of smiles that we're seeing here on the stage. This is our 2022 class of ESA astronauts.
After a marathon year sifting through a record-breaking pool of more than 22,000 applicants, ESA finally introduced the 17 candidates who made it. With backgrounds in engineering, jet piloting, astrophysics or medicine, the new astronauts already have an exceptional range of skills. But going into space will require learning new ones.
There are a number of skills that you need to acquire in order to do an ISS long duration mission, which the new astronauts will do. There are of course the technical skills, how do you operate in space, how do you install experiments, how do you work with power supplies in space. There are also more operational skills like robotics, how do you manipulate the robotic arm, how do you conduct an EVA, and of course there are also more skills related to the understanding of the space environment, the understanding of the medical environment, how the space influences your own body when you're operating on board of the space station. And last but not least, also human performance and behavior training, meaning how does my behavior influence the effectiveness of the crew, the behavior of the other crew members, and how can we most effectively work together as a team. In the next few months, the astronauts here in the European Astronaut Center will go through the basic training. The basic training will give them, for example, basic robotics training. It's not on the SSRMS itself, the robotic arm that is on the space station, but how to understand how do I operate robotic arms in space. They will have basic EVA training, the basics of how do I communicate under an EVA, how do I get into the foot restraints for an EVA, how do I work with connectors in EVA, for example. They will have technical training about our Columbus module, to be a user, to be an operator, to be a specialist on the Columbus module, and they will have also already some start of the science training that they will have. And not to forget, of course, a big part, because that will be, for a lot of them, will be new Russian language training. The first flight for this new class of astronauts will happen in 2026. And after that, we hope that we have a flight every year. So there are 5 new career astronauts selected, so we hope that by 2030 all of them will have had their first mission to space. The reserve astronauts, they stay affiliated with their current organization. They continue to do the job that they are doing now. However, we will invite them here to ESA to update them on the future of human spaceflight programs, on our exploration program, Terra Novae, because of course they are now very well known in their respective countries. They have a lot of invitations to speak, to go to PR events, and we want them to be aware of what ESA stands for, what we are doing in exploration with ESA. On the other hand, we might also use them, their expertise, because they are also very high-level experts for certain tasks that we want to do in ESA. We want to use the expertise that John has as a subject expert, of course, with the disability that he has, to see what would it take to fly somebody like John to the space station for a fully functional, fully operational mission. Not just for 10 days to float in space, because that is not the purpose of the ESA program. The purpose is, can we use people with a disability as a full-fledged astronaut, and what would it take to do that?
I think that I can bring lots of things to the feasibility study, but I think in particular I can bring inspiration. You know, inspiration that science is for everyone, but inspiration that potentially space is for everyone.
We are now at the Copernican Museum in Monte Mario, and these globes represent the Earth and the sky as astronomers saw them centuries ago. Did they ever dream that humans would one day fly into space? Well, fiction is now reality, and the next ESA astronaut to fly to the International Space Station is Andreas Mogensen. He's busy these days, training for his second mission in space called Hugin. Andreas Mogensen belongs to the generation of astronauts selected some 13 years ago. After his initial training, he was launched into space in 2015, and he spent 10 days on the International Space Station. Now he's getting ready for his first long-duration mission.
This will bring you in the situation of warming.
Training is taking place all over the world, but we managed to catch up with him during a brief stopover at the European Astronaut Center in Darmstadt, Germany.
I'm here at the European Astronaut Center for my last session of Columbus training at specialist level before I launch to the International Space Station in approximately 6 months. I'm incredibly excited, but there's still a lot of training to go before I'm ready to launch, especially when it comes to the Dragon spacecraft, where I'll be the first European pilot. That's a huge honor and responsibility, but something I'm really looking forward to. I'm excited and ready for my mission. I hope you are too, and are ready to follow along.
And of course, you can follow Andreas on social media to get all the updates on his mission. So this is an amazing orrery from the 18th century, and it represents the solar system, of course, but not all the planets are there because they just hadn't been discovered yet. So you can see the Sun here, the Earth, and the next ESA astronaut to fly in the future might be traveling to here. The Artemis program aims at returning humans to the Moon. At the end of 2022, NASA's giant SLS rocket launched a spacecraft called Orion to fly beyond the Moon and return safely to Earth. And it did. The uncrewed Artemis 1 mission was a clear success. Preparations are now in full swing for the next Artemis missions, and Europeans are contributing in 2 ways. First, they will provide the European service module that gives air, electricity, water and propulsion to the Orion capsule and their occupants. But ESA also secured free seats on future crewed Artemis missions, and by the end of this decade, a European astronaut will walk on the Moon. That's a giant leap for Europe.
Now, history is always in the making in the space sector, and it is surely true for ESA's latest mission to explore Jupiter, the largest planet in the solar system, and 3 of its moons. The mission is called JUICE, and the spacecraft is due to launch April this year.
In the last 8 years, we have been developing our spacecraft. We have been designing, building, and testing it. But even before then, for many years, scientists and engineers, they have been working on the definition of this mission, doing studies, doing feasibility analysis. So it's almost 20 years from the first idea of going and studying the icy moons of Jupiter to the launch that will happen in a couple of months.
20 years is really quite a long time.
It is.
Yeah, and also when you think about it, really, I mean, the taste of juice is very sweet. But for this mission, what is so exciting about it?
There are many reasons to be excited about JUICE, definitely. Well, JUICE, first of all, is the first European-led mission to the Jupiter system. This is something to be very proud about. This is a major achievement for Europe. And then it's also a step forward to the knowledge and the understanding of our universe. Where are we coming from? What will be our future in the solar system? So questions that have been coming with the mankind since the early ages. And JUICE will help answering to these questions.
So, as in every other mission, surely there are challenges that the team has had to overcome before we got to this stage. What are they and how were they able to overcome these challenges?
Indeed, during the development phase, we have faced many technical challenges and human challenges. If I can just mention a few, in Jupiter there is a very high level of radiation, so we had to screen all the electronic units to survive in such environment, a harsh environment. The spacecraft has to sustain an extreme range of temperature, hot when it will do the flyby of Venus and cold when it will be in the Jupiter system. Then Jupiter is millions of kilometers away. Therefore, the spacecraft has to have a navigation system and a certain level of autonomy that will allow to perform all the operations completely autonomously and recover from possible failure without intervention on Earth. And then last but not least, there is also the human challenge, because we need to ensure a continuity of the knowledge all along the development and the operation of the spacecraft, so the overall life of the mission. So yes, sending a spacecraft to Jupiter is not a walk in the park like we are doing now.
Yeah. And when do we expect to receive the scientific results and the knowledge from this mission?
Well, the spacecraft will reach Jupiter in July 2031. And soon after, all the scientific operation will start. And the data will be transmitted to Earth on a regular basis. Therefore, from that moment, the scientists will be able to start and draw conclusions or to start drawing discoveries out of this data. So, relatively soon, once we are in the Jupiter system.
So, a very busy few months ahead for you. How do you feel about it?
We have indeed the couple of months before the launch in April. And the launch campaign is usually a very exciting period. On the other side, it's also very, very intense, and you're not allowed to make mistakes. But we are ready for this last challenge, to pick up this last challenge and getting our spacecraft ready for launch.
And don't miss the launch program for JUICE, live from Kourou on Thursday, 13th April on ESA Web TV.
Fushino Space Center, 12 minutes.
Let's get started. Drive safe. In 200 meters, at the roundabout, continue straight.
So we all take it for granted that our phones are giving us the directions when we're traveling or when we are lost, but the technology behind it is actually fairly new. We're about to celebrate the 10th anniversary of the very first time the Europeans were able to fix a precise location on a map, and that event marked the birth of Galileo, Europe's very own global navigation satellite system. Vincent tells us more.
And then we declare success.
March 12, 2013 was a huge day for the Galileo team. For the first time, 4 Galileo satellites orbiting the Earth were able to send down their signal to the navigation lab room in the Netherlands, giving a precise location for longitude, latitude and altitude, and thus confirming that European navigation system was indeed working.
Good afternoon.
Good afternoon, Marco.
Nice to see you.
Thank you for having us. Thank you.
Welcome to the European Space Agency Navigation Laboratory.
Thank you for having us, Marco.
Marco Falcone was in that same room 10 years ago, working as the head of Galileo system and operations.
In this room, there was our test user receiver. This is the first receiver that computed the positioning. And here you see the main machine interface of this receiver with some analysis software that is showing, we call this a sky plot in technical terms. It's basically showing you the sky, and the position, every point is corresponds to a dot in this diagram, and then you see the accuracy. In this case, you are within a radius of 5 meters. And here you see, for instance, these are the codes. This is the full constellation. You see every square corresponds to a satellite, and as you can see, there are 4. That are the 4 we used for doing the position fix. Okay, then if you see nowadays there are 28.
It must have been quite an exhilarating experience for you when you got the signals on the computer screen, right?
Yeah, because you see it working. And imagine I was at the control center the day before. So telling the operators, this is why our job is fantastic. You see what I mean?
Yeah.
You can really make it, make it happen. Is what is nice in the end of our job.
The future looks quite promising for the Galileo navigation system with the 2nd generation currently in development. What capabilities would they bring to the table this time?
The Galileo 2nd generation development has started because now we are close to reach full operational capability. It's a lifetime more or less of 20 years. So we need now to develop the system for the next 20 years. And the satellites will have a lot of new capabilities, the 2nd generation satellites. Higher power, much higher power, so that you can receive the signal in all conditions. And also another feature important is electric propulsion for orbit raising, because this will allow to reduce launcher's costs. So all in all, in a nutshell, this is a high flexible system. Why flexible? Because it has to provide the services to users for the 20 years to come, and we don't know yet what the users will want in 20 years from now. So it is very important to have this flexibility. And I'm sure the Galileo 2nd generation will be a success.
And maybe even more reliable and accurate navigation for users as well.
The user can already now be able to compute a position of the order of 20 to 30 centimeters with a certain few minutes convergence time. So already the system that is currently in operation is providing very important services, very accurate, very robust. So this is thanks to the flexibility built in the design that we started already 20 years ago.
Indeed, the 2nd generation is quite promising. Thank you so much, Marco, for taking the time to talk to us.
It's a pleasure.
And we wish you all the best for the future.
Thank you.
Thank you.
And keep an eye on the ESA portal for the anniversary in March.
So we've now reached the Fucino Space Center in the Abruzzo Mountains. With more than 170 antennas, it's one of the largest teleports in the world for civilian use. Some of these antennas pick up signals from Galileo satellites, and some others have been playing a key role in a more recent launch.
That day, the weather at Europe Spaceport in Kourou, French Guiana, was ideal for launching a, well, weather satellite. On 13th of December, an Ariane 5 rocket successfully took into orbit the first of a new generation of groundbreaking satellites. The Meteosat 3rd generation Imager 1 and its 5 successors will provide crucial data not only to help long-term climate monitoring, but also to improve forecasts of severe weather. And that's thanks to innovative instruments, including a novel lightning catcher.
This is a lightning instrument that will serve very much to give us information related to thunderstorms. Very relevant, for example, for civil aviation activities on the Atlantic. And then on top of that, it has an instrument which is a flexible combined instrument that will give us the state of the atmosphere, information that will come every 2.5 minutes compared to what we had in the past. And so with a much increased pace in terms of time range, in terms of resolution, and in terms also of providing information which is more accurate and more advanced to what we had until now.
So we are now in the control room where it all happened during the launch. And Ernesto, you were the man in charge that day, and you and your teams prepared for all kinds of scenarios. Did you get the best one you could have hoped for?
Siamo molto soddisfatti dei risultati di questa attività di lancio di MTG I1. Ci eravamo preparati molto bene con una campagna di simulazione molto lunga, molto sfidante. Il team ha reagito molto bene, ha eseguito tutte le operazioni previste, ha risolto le anomalie che abbiamo incontrato e alla fine abbiamo rilasciato il satellite ad EUMETSAT nella configurazione attesa.
Okay, and how do you control a satellite like this in the very first phases? What are the critical parts of a launch like this?
Allora, ci sono diverse attività critiche. All'inizio, nella prima orbita, c'è il deployment dei pannelli solari, l'inizializzazione del sistema propulsivo e poi soprattutto le manovre orbitali, che sono quelle per il trasferimento dall'orbita iniziale in cui il satellite è rilasciato dal lanciatore all'orbita geostazionaria.
So MTG I1 is now hovering some 36,000 kilometers above the equator, and we're about to receive its very first data. So how will this work and what do we do with this data?
Gli strumenti a bordo di MTG acquisiscono una grossa quantità di dati, pensa che saranno all'incirca 28 volte superiori una volta che la costellazione sarà completamente deployata rispetto alla seconda generazione. Questi dati verranno acquisiti dalla stazione di Lario nel nord Italia e da lì poi inviati ad EUMETSAT nel centro di Darmstadt, in cui verranno processati e inviati ai servizi meteorologici nazionali.
What will this MTG new generation of satellite will change for weather forecasting?
Sarà un grosso miglioramento perché migliorerà le prestazioni attualmente esistenti con la seconda generazione. Fondamentalmente le immagini acquisite saranno con una risoluzione maggiore, quindi riusciranno a vedere dei dettagli più piccoli e anche la velocità di acquisizione sarà maggiore, quindi le immagini arriveranno a una frequenza più alta. Questo consentirà agli esperti di meteorologia di prevedere fenomeni violenti e severi, quindi a rischio per le vite umane, molto più rapidamente e con maggiore affidabilità.
Ernesto, thank you very much for your time.
Grazie a te.
This is the antenna that took control of the MTG satellite immediately after it separated from the rocket. And it's a very similar one that's going to receive the very first data very soon of a satellite in orbit. Don't miss updates on the MTG's first images by following ESA Earth observation on social media.
We are almost finished, but here are some other news in brief.
The hundreds of missions that will launch to the moon over the next decade and beyond will need technological support to help them navigate and communicate with Earth. ESA is now inviting companies in Europe and Canada to provide these services by putting a constellation of satellites around the moon. The initiative, called Moonlight, will also benefit the future permanent base due to be built on the lunar South Pole, the Lunar Gateway.
How did the universe originate, and why is it expanding at an accelerating rate today? These are some of the questions the Euclid mission will try to answer. The Euclid Space Telescope is almost ready for launch, and after a few more tests, it is due to depart to the skies in the summer 2023. Once it has reached its destination at about 1.5 million kilometers away from Earth, Scientists hope to learn more about dark matter and dark energy, which could make up more than 95% of our universe.
And that's it from us, from all the Web TV team. Thanks for watching.
And to keep up to date with space news, visit the ESA website and follow us on social media.
Goodbye.